Finished 1 through 10 in the other class, so it's going to be your responsibility to check that out. So let's go through this. This is the part where a lot of people have trouble with anyway, so it's probably better for you guys that I go over it live and in person. So here we go. Let's take a look at starting at 11. Look what kind of triangle it says. Now look at how they, first of all, before you look at the triangle, look at what the instructions were. The answers need to be exact, and they need to be simplified. And what does it say? No decimals. Could you even imagine that anybody would try to write an answer down with a decimal for these? I couldn't imagine. Could you? No, I couldn't, because it says right there, no decimals. But still, of course, I had people writing down answers that they put into a calculator and wrote down as a decimal.
God bless you.
Go figure. All right, here we go. Let's take a look at this. There is a relationship. This is a 45, 45, 90 triangle, and you have to know these relationships. Actually, it's going to be given to you. Remember I said I was going to give you a little formula sheet?
Oh, thanks, dude.
Does everybody quit? I see like 3 people with notes out, and everybody else just sitting there. Okay, I know it's last day of school, but it is a day of school, and it's still class. So let's do this. So I am going to give you a little formula, and it will have the relationships between the 45, 40. I'm waiting for you. Shh. Everybody ready now? I'm going to give you the relationships on that little formula sheet. 45, 45, 30, 60, 90 triangles. I'll even give you the SOHCAHTOA and all that kind of stuff. Okay, you should know that already, but it'll be on there, so you don't have to memorize it, but you need to know how to use it, though. Okay, it's no use knowing it and having it in front of you if you don't know how to apply it. This number 11 is about the easiest one that you could possibly do, because the relationship is that the hypotenuse is equal to the square root of 2 times one of the legs. Hear what I said? The hypotenuse is equal to the square root of 2 times one of the legs. So what do? You look at, see what they give you. They give you one of the legs, and they ask for the hypotenuse. So what do I do with that? Hypotenuse, which is x, is equal to the square root of 2 times this. How do I write that? How do I take 16 and multiply it by the square root of 2? That's it. I just write it. 16 square root of 2. That's all I do. All right, get this right, please, on the test. All right, it was so frustrating looking at how many people miss this. All right, it's a very, very basic, simple problem. You have to get it right. I mean, this is one of those ones I practically give to you. All right, you just have to take it. And some of you guys aren't even taking it. You got to think a little bit. All right, and there it is. And I'll even give you the formula this time if you don't remember the formula. I had people writing 16 times the square root of 3, and they're getting the formulas mixed up. All right, this is 16 square root of 2. You just write it like that. It's exact because it's got a square root. It's simplified because you can't simplify it, you can't reduce anything, and there's no decimals. All right, so that is your answer. Look at this one. This is a little bit, well, this is just as easy as number 11. This is a 30, 60, 90 triangle. Now, there's a relationship for that. Let's write that down. There's 2 of them, actually. The hypotenuse is equal to twice the short side. And the long side is equal to the square root of 3 times the short side. Again, you don't have to memorize it. I'm going to give you a formula sheet for this thing on the final. But you have to know how to interpret it. What does it mean? Well, look what we have here. What do we have? What is that 9? Is it the hypotenuse? Is it the long side? Is it the short side? Which one is it? It's the short side. How do you know it's the short side? Not just because it looks like it, but because it's what? It's opposite the 30-degree angle, which is the smallest angle. Right, so you know that's the short side. What is this side right here? That's the longer leg, right? It's not the hypotenuse, it's the long leg. That's right here. And how do we know that? Because it's opposite the 60. There you go. That's so weird. Well, maybe, I don't know. There it goes. Wow. So was that like 30 seconds it went? I don't know why it does that. All right. Yeah, sure. So here we go. What do we know? We know the short side. What are we trying to find? The long side. Again, it's just as easy as number 11. It's what? It's 9 times the square root of 3, because it's right here. The long side is equal to the square root of 3 times the short side. The short side is 9. 9 times the square root of 3. We just write it like that, and that's it. It's another gimme problem. Okay, you didn't have to do any math. You didn't have to do any algebra. You didn't have to use a calculator. It's just really easy. Would you agree with me? I'm not just saying that because I'm the teacher. I know I get blamed a lot for saying things are really easy and maybe they're not so easy for you. But you got to admit, those two are pretty easy, aren't they? Yeah. Okay. Now this one's a little bit more difficult. So let's see this one. You're trying to find the hypotenuse this time, right? So this is what you're trying to find. Now, it would be nice if you knew the short side, but we don't know the short side, do we? All right, this one takes a little bit of thought. This is not quite as easy. Let me scooch it over so I have some room to write. So what we need to do is we need to find the short side. We need to find the short side right here. Well, what do we know? We know the long side. So here's our relationship. If I know the long side, how do I find the short side? Right, we divide it by the square root of 3, don't we? Okay, if I'm trying to find the short side, I have to get rid of the square root of 3. And how do I get rid of it? I divide it. So it's the long side, 7, divided by the square root of 3. You use this formula right here, and you're solving for the short side, so you get rid of the square root of 3. It's being multiplied. How do you get rid of it? You divide it. All right, that's basic Algebra 1 principle right there. Now, we don't want to keep our answer like this, do we? Because it's not simplified. Why is this not simplified? Somebody talk to me. Why is that not simplified? You can't have a square root on the bottom, right? Okay, so how do we get rid of it? On the bottom, we multiply the top and bottom by the square root of 3. Right? We've done this a couple dozen times at least. So what happens here? Let's multiply the top. That's just 7 square root of 3. What's the bottom? What's square root of 3 times square root of 3? Just plain old 3. So what is this? Is that my answer? No, that's the what? That's the short side. That's just that side right there. That's not what we're trying to solve for. We're trying to solve for this. Well, that's the hypotenuse. What's the relationship between the hypotenuse and the short side? It's twice as much. It's double it, right? So, yeah. So take 7 square root of 3 over 3 and double it. Multiply it by 2. How do I multiply those things together? Just the 7 and the 2. Multiply those together. It's 14, and you write the rest of it down exactly the way it looks. And that's your answer right there. Okay, so that is 14 square root of 3 over 3. I had to give you one of those that you had to do a little bit of work with, didn't I? I mean, it wouldn't have been fun just to, not to think. So it's nice to think a little bit, all right? So you had to do 2 steps. You had to find the short side, simplify it, and then once you find the short side, finding the hypotenuse is pretty easy. You just double it. All right, so I'm showing you this. When we reviewed for the test, we went over one of these, and so you have that at your disposal many different times. You just have to learn it. Okay, it's up to you to learn it. All right, enough of that. Let's get rid of some stuff here. Let's get rid of all of this. Just to clean it up a little bit. And let's get rid of this stuff right here. Alright, now we're working with a clean slate again. And we're doing 11, right? Oh, we did those. Yeah, we sure did. Okay, we're doing 14. Let's make this a little bit bigger. How's that? Alright. You thought those other two were easy with that 45 and that 30, 60, 90, right? This is even easier. I'm telling you. I think it's just as easy at the very least. We have to find the sine of A. And look what it says. Express the ratio as a what? As a fraction. So we're writing our answer as a fraction. We're not solving for the angle. Okay, we're finding the sine of angle A. So let's find where angle A is. It's right here. Now what's our little trig function thing? How do we remember it? Right. SOHCAHTOA. All right. That's also going to be on that little formula sheet thing I'm going to give you, but you should know that already. All right. So what is the sine? The sine is OH. What does that mean? It means opposite over what? Hypotenuse. So the sine of A is the opposite, which is 12, over the hypotenuse, which is 15. Now, I didn't say even to reduce the fraction, did I? If you want to keep it like that, that's perfectly fine. Okay, you could reduce it if you wanted to. 3 goes into both of those 4 times and 5 times. Right? So you could have written it either one of those answers. If you would have put it into calculator, you would have gotten 0.8. Would that be an acceptable answer if you wrote 0.8? No, it wouldn't, because what does it say? Write it as a fraction. Okay, so even though that's the correct actual number, all right, 0.8 is the same thing as 4/5. it's not written correctly. Okay, it's not written according to the instructions. All right, so you need to make sure you do that. What do you think? You got to admit that was super easy, wasn't it? Yeah. So we're only doing half the test today, right? Because we already did it in the other class. But so far, we've had 4 problems that were super easy. You didn't have to really do any math at all. All you had to do is look, write down an answer, bang, you're done. Just in half of the test. Okay, 4 of them were super easy. Same thing with C. C is super easy. Look at C. It says find the what? The tangent of it. So let's look over here at tangent. It's opposite over adjacent. Which one is opposite angle C? The 9 is. What's adjacent to the angle C? The 12 is. So we just write 9 over 12, and you're done. You could simplify it if you wanted to. I'm not making you do this. It doesn't say on here to simplify it, but if I asked you to, 3 goes into both of those 3 times, 4 times. That would be 3 over 4 or 9 over 12. I don't care which one you give me if I don't ask you to reduce it. Make sense? Destiny, you getting all this? Why were you complaining about the math? Because you're not even, it's not even a thought in your mind right now, is it? Huh? Well, wouldn't you be more depressed if you don't know how to do these problems on the final? Wouldn't it be a lot better to pay attention? Listen to me. Listen to me. Listen to me. Listen to me. This is a rhetorical question, not really causing a response here. Wouldn't it be a lot better, okay, to pay attention now, learn how to do some of these things, and then actually get the question right on the final exam? Okay, I think that would be much better, don't you? Okay, and I would like it much better if I got the answer right on the final exam. So I think, to me, it's worth. You're in here anyway. Okay, I'm sitting right in front of you. All right, you might as well listen and pay attention and write this stuff down because it's going to help you. I'm trying to do this to help you, not to torture you. And it seems like you guys think I'm trying to torture you, but I'm trying to help you out, okay? What other teacher goes over every single problem that's going to be on there, okay? All of them do? Nah. Yeah. Well, anyway, so I'm another one, all right? So I'm doing it as well. So here we go. All right, listen. Again, rhetorical question, really. Let's take a look at this. Is this one of our special triangles? Is this 45, 45, 30, 60? Is it any of those kind of things? No. Okay, it's a weird angle, 37 degrees. So what kind of thing am I going to use? Am I going to do Pythagorean theorem? Okay, because we do Pythagorean theorem with right triangles, don't we? But not in this case, because I don't know 2 sides. I only know 1 side. And I got to find this. So I use the trig functions. That problem that we just finished doing with that sine and tangent thing, that was kind of warming you up to this, wasn't it? So what I'm going to do is I'm going to label these things. If I'm using this angle, 37 degrees, what is this x in relationship to this angle? It's opposite. And what is this 7 in relationship to the 37? That's adjacent. No, we have a trig function with opposite and adjacent. Which one is it? It's the tangent. That's right. It's the tangent. So we take the tangent of the angle, which is 37 degrees, and that's equal to opposite over adjacent, x over 7. Now you have to do a little bit of math. It's not much. Multiply both sides by 7. That was all the math you really had to do. Okay? When I say math, I'm talking algebra step. Okay? And now you just stick that into a calculator and you're good to go. So let's put that into a calculator. Turn it on. There we go. So it's 7 tangent of 37. Right? And that equals 5.3 approximately. So x is about 5.3. And what's it say? Round the sides to the nearest what? 10th. Is that rounded to the nearest 10th? Absolutely. Do I put 2 decimal places when it says round to the nearest 10th?
No.
No. I put how many? 1. You can't believe how many people put 2 decimal places for this. Or some people rounded it to the nearest number. They just put a 5 there. Okay, it says specifically right here, it's even bold, round it to the nearest 10th. That's the sides. What about the angle? Number 17 is an angle. What does it say to round the angle to?
Degree.
Round the angle to the nearest degree, which means there's no decimals. So if it was like, I don't know, 27.3, do I write 27.3? No, I would write what? Just 27, all right? So you got to follow instructions. And I harped and harped on that before you took the test, and still people are not rounding correctly. Just don't understand why you wouldn't, but maybe that's just me. Let's take a look at this. Here's the angle we're going to solve for. Look at these two sides right here. What is this 4 to this angle? It's adjacent. The 10, hypotenuse. Which trig function uses adjacent and hypotenuse? AH, which is cosine, right? So we're going to use the cosine. Let's put that right here. So the cosine of what? What angle? X, because we don't know what the angle is equal to the adjacent over the hypotenuse, which is 4 over 10. We don't leave it like that. We got to get x by itself. Very good. We got to take the inverse of the cosine. So x equals the inverse cosine of 4 over 10. All right, and then you put that in your calculator. Let's put this in our calculator. So on this calculator, how do you hit inverse? Second function cosine. You do that on every calculator, to tell you the truth. But if you have a TI-30XA, you would hit 4 divided by 10, hit equals, then you would hit second function cosine. On this type of calculator, you hit second function cosine first, then you put 4 divided by 10. And then you get 66. What does it say? Round to the nearest what? Degree. Do I put 66.4? No, I just put 66 because this 4 does not round that up, so it's just 66 degrees. And according to the instructions, that's the only acceptable answer right there. 66 degrees. No point anything. All right? One more, well, 2 more of these. How about that? All right, let's do this one right here. Now, this one's not a right triangle. So we can't just use a regular trig function. So we're going to have to use something else. What else is at our disposal? Okay, and what is that? Law. There was law of something.
Sines.
Law of sines and law of
Cosines.
cosines. All right. So law of sines and law of cosines. So Dan, you were saying that side angle and angle side. What do we have here? I've got an angle and a side that's not in between there. So I've got angle side. So we use the law of sines. Yes. A law. I think I do. Yeah. I have law of sines and law of cosines on the formula sheet. Yep. Okay. So you got to know how to use it, though, and you got to know which one to use. On this case, you use the law of sines. So how do we do that? You always look opposite. We're going to use this side and this angle, and then we're going to use this side, excuse me, x, and this angle, 80 degrees. All right? So what's the law of sines? Now, if I'm solving for x, I like to put that on the top. Okay, I think it's a lot easier to work with it like that. So I'm going to put x over the sine of 80, because that's the one that's across from. Look, and you do the other pair in the same order, right? You put the side over the sine of the angle. So the side is 12, and the sine of 40. Everybody got that? It's law of sines. It's pretty easy. So watch what I can do. I got to get x by itself. I have to get rid of the sine of 80. I don't take the inverse because I'm trying to get rid of the whole sine of 80. How do I get rid of that whole thing? I multiply by the sine of 80. All right, so it canceled out here. And so now we're ready to put that into a calculator. Let's put that right here. And let's see what we do. We go 12, sine of 80, and we divide that by the sine of 40. And that equals about 18 point. Now, this is a side, so what are we rounding it to? Nearest tenth. So what would that be? It's 0.4, right? The 8 rounds the 3 up to a 4, so it's 18.4. So that should be your answer. And that's how long that side is right there. Make sense? All right. One more. One more of these kind. Scooch this over, give me some room. Look what we have here. We've got a side, and we've got an angle, and we've got a side. Which one of those laws do we use with side, angle, side? Law of cosines. If you can't remember that, go back and watch the video and I explain it. Okay, or look in the book, or look in your notes. Okay, you don't have to watch the video every time. Go back in your notes and see it. So we're going to use the law of cosines. The law of cosines says this. I'll write it all out. And it's going to be written out on that formula sheet. All right, everybody with me on this? So now, what is our c in this situation? It's x. And what's the a and the b? 13 and the 20. All right, so I've got 13 squared plus 20 squared minus 2, again, 13 and 20 again, and then the cosine of the angle that's opposite this side, which is 103. All right? Really, it's just a matter of plugging this into a calculator, which isn't always that easy on this. What's the key thing to remember on your calculator? Use the parentheses. Use one right here and use one right there. Put it in a different color. I do that every time so it stands out a little bit. So let's put this in the calculator. I'm not even going to worry about this squared thing until the end. All right? I'll put all this stuff in the calculator right here. Then what do I do to it? After I put all this stuff into the calculator, what do I do to it to get x? Take the square root of it. Good. So let's do this stuff. I've got 13 squared plus 20 squared minus, now, what's in red? The parentheses. I think it's very important that you put that there. 2 times 13 times 20. Then cosine. Oh, I put 21, didn't I? At least I caught it. Then cosine of 103. Now watch what I'm going to do. See how that 103 gives you a parentheses right there? So I put a parentheses just to close that one in, but then I got to close this one as well, don't I? So I put another parentheses. Everybody understand that? Why I put the two of them? All right, now I can hit equals or enter, and I get this big old number. Is that how long that side is? 685? There's no way. Not if that's 13 and that's 20. There's no way that would be 685. But what do I have to do? We talked about this a second ago. I have to take the square root because x squared is equal to all that stuff. So I take the square root of it. So watch, I take the square root. In this calculator, what do I put in? The answer, right? The square root of the answer equals, there it is. That looks a little better, doesn't it? About 26. Now this is a side, so what am I rounding it to? To one decimal place, the tens place. So that 9 rounds that 1 up to a 2, so it's 26.2. So x is 26.2. There you go. What do you think of that? That's good stuff, isn't it? It's not that hard. You don't even have to do any algebra with that. All you got to do is plug the numbers into the formula, stick it into a calculator, and I'm giving you the formula. So you can't complain about that, can you? All right, let's see. There's a flagpole in front of the school. Jen walks 60 feet away from the tower. Now, it's probably a bad use of words, but what do they mean from the tower? From the what? From the flagpole. That's what they're referring to. Okay. So she measures the angle of elevation from her position to the top of the flagpole to be 53. How tall is the flagpole? So let's draw the picture. You don't have to be a great artist, okay? Which I am definitely not. All you need is a ground. Yeah, because my machine here makes straight lines, so that makes it even nicer. So thanks so much. So what's this? This is the ground. What's this line up and down here? That's the flagpole, okay? And that just finishes up our triangle. So let's see. There's a flagpole in front of the school. Jen walks 60 feet away from the tower. The tower means the flagpole. So here's the flagpole. She walks 70 feet away from it. So she ends up right here. Right? So that's 70. She measures the angle of elevation. What does that mean? She's right here. The angle of elevation, and I think I even told you this when you took this. The angle of elevation is that angle that she's looking up at the top of the flagpole. Okay, here's the top of the flagpole. So that angle of elevation is 53 degrees. It's not really drawn to scale, but it's good enough. How tall is the flagpole? So which one is the flagpole? It's this one right here. We'll call it H for height. Is that all right? And those X's are just a marker, right? Just from where she started to where she ended up. That's what those X's are. So look, this looks just like one of these right here, doesn't it? Looks almost just like this. Exactly like this one. Would you agree? Because look, they give you an angle here, they give you the adjacent, and they ask for the opposite. So it's exactly like this problem. We just had to draw the problem out. That's the only deal. All right. So what are we going to use? What is this side? This is opposite. What is this side? This is adjacent. So what gives you opposite and adjacent? The tangent. So the tangent of 53 degrees is equal to the opposite, which is h, over the adjacent, which is 70. Multiply both sides by 70, and then you stick that into a calculator. So it's 70 tangent 53. That's it. 92 point. And this one doesn't say how to round it, does it? All right. So you could have kept it 93. You could have made it 92.9. All right. Well, you have to look to see what you did. You might, right. You have to have it in. You have to have it in degrees. Okay. If you have a calculator like this, make sure you hit mode and make sure that degree is highlighted. If you use a graphing calculator, most of your other calculators, the little scientific ones, usually defaults to degrees. You don't have to worry about it. But this calculator, a lot of times it defaults to radians, and you have to change it to degrees. Yes, sir. All right. Well, look at that. We are officially finished. We've gone through every single problem for every question on the whole second semester. Okay? So that's what the test is going to look like. The tests are going to be problems that are taken from your old tests. All right? It's going to be 40 problems, just like the midterm. Okay? It's going to be 40 problems, and they'll look just like this, and don't know what else to tell you. I think I've gone way above and beyond as far as helping you review for this thing. Wouldn't you agree with that?
I think I would.
Yeah, so that's it. Chapter 8. And that's it. Shh. All right, we good? Please make sure you watch the videos. You only got one more weekend. Don't say, oh, this is my last weekend, I'm not going to do anything. That's not what you need to do. You should say, this is my last weekend. This is when I'm really going to buckle down and work hard. All right? Are you guys listening to me? Not when you're talking, you're not. Have a seat. This is not the weekend just to mess around and say, oh, goodness, school's over. Thank goodness all I got is finals. No, it's a pretty big chunk of your grade. It's 5% of your whole entire year's grade. You may not think 5% is much, but it averages in with your other marking periods and your midterm, okay? And you might be right on the edge of passing, and this might be your only hope of passing. You might be right on the edge of getting a B or an A, and this might be the thing that determines whether you get that B instead of a C or whether you get that A instead of a B. So this could make that difference, absolutely. It'll go in your final average. No. Yeah, your final average, not your fourth marking period grade. It has nothing to do with that. That's already settled and done. Okay, it's your final average is the thing that counts. Okay, that's what, if you transfer to another school or if colleges look at your your grades when you're younger and stuff like that, that's the grade that they're going to look at. They're not going to look at your second marking period grade your sophomore year. Okay, they're going to look at your total over average, and it is important. So don't blow it off. All right, make sure you study, make sure you prepare for it, be ready for it. Don't just walk in saying, oh yeah, I think I have a test today. All right, you can't be doing that stuff. What is this, third period, right? So we take this Tuesday, the first section,
So
whatever,
we meet
like
here
8,
Tuesday.
like 8:10 or something like that, I think. Okay?
Yeah, it's 8:20.
8:20. Okay. All right, that's it. Everybody want to say goodbye since our last video? Say it.